Welcome back. We're going to close out this section by talking about converting equations between polar and Cartesian coordinate systems. Okay. So remember our relationships. Those still hold and they are our key. So x equals r cosine theta. Y equals r sine theta. X squared plus r squared. Whoops, sorry. That's wrong. X squared plus y squared equals r squared. And I'm going to remind you also that cosine squared theta plus sine squared theta equals 1. Okay, so let's start with this one. Let's rewrite the Cartesian equation. X squared plus y squared equals 6y as a polar equation. Okay, so we remember that x squared plus y squared equals r squared. So I've got x squared plus y squared equals 6y. Well, this is r squared because x squared plus y squared equals r squared. So that means that r squared equals 6y. And now we remember that y equals r sine theta. So that means that r squared equals 6r sine theta. Now we're not done yet. Polar equations always are written in the form r equals. So what we're going to do is we're going to pull everything to the left-hand side. So we end up with r squared minus 6r sine theta equals 0. Factor out an r. And that means then that r equals 0 or r equals 6 sine theta. Now this first guy, this guy is called the trivial solution. And we reject him. And this is our polar equation. Now how can we check that? Well, if we go to Desmos, we can put in the Cartesian equation, and we see we get an offset circle, and radius 5, well, diameter 5, 6, and that looks like what we remember seeing. So r equals 6 sine theta. Sure enough, we did it right. We got the same equation in both coordinate systems. Okay. So that's your basic technique for going from Cartesian to polar. Sometimes it gets a little trickier, but that's really the basic technique. Let's go the other way. This sometimes gets more interesting. Let's rewrite the polar equation r equals sine 2 theta in Cartesian form. And let's remember what we've got. So these are our basic relationships. Okay. Well, none of those have a 2 theta. Well, so the first thing we have to do is apply a double angle formula. So we're going to take our equation, r equals sine 2 theta, and we're going to rewrite that using the double angle formula as r equals to sine theta cosine theta. Now we remember that sine theta equals y over r, and cosine theta equals x over r. We have to get rid of all those r's, so let's multiply through by r squared on both sides. So we get r to the third equals 2xy. Oh, that works, because we remember that r squared equals x squared plus y squared, which means r equals the square root of x squared plus y squared. Right? So what I have is that, and this is the same thing as x squared plus y squared to the 1/2 power. So r to the third is x squared plus y squared to the 1/2 power raised to the third power. And we should write that correctly as x squared plus y squared to the 3/2 power equals 2xy. And because our polar coordinates, our polar equations almost always are going to describe circles and roses and lemicons and spirals, we are not going to be able to get a function. So we're not going to be able to solve this for y. So we're just going to leave it like that. Now, how do we check ourselves? Well, we check ourselves the same way we did a minute ago. This time we're going to start with our polar equation because it's what was given to me. So we're going to start with r equals sine 2 theta. Oh, okay, we get a cute little 4-petal rose. Okay, so now let's check and see what we get when we check our Cartesian form. So x squared plus y squared raised to the 3/2 power equals 2xy. Oh, we only got half of it. Why? Oh, because I've got a plus or a minus. So I need the other one too, don't I? Well, let's just duplicate this and take the negative one. There we go. Now I've got the other half. Might be better to put the negative on the other side. It doesn't really matter. So we would have to have two answers here. X squared plus y squared to the 3/2 power equals negative 2xy, if we wanted to get the whole 4-petal shape. Typically, when you're doing these in the homework, they're only going to ask for one, and this one is going to be your correct one. So typically in the homework, you're just going to take the principal root. All right, these get a little tricky, so be sure and reach out if you have any questions. I'll talk to you again soon.